Hello, class 12th physics, chapter dual nature of radiation and matter, topic de Broglie hypothesis. Well, why is this required? It gives a revolutionary idea that light is not only particle but it is wave also. It has dual nature, and not only uh, light alone but every moving object behaves like wave. We can define it as every moving object and radiation has both wave as well as particle nature. It means light is both radiation, wave, and particle, and also every moving object like this sketch pen is moving, so there is a wave associated with all it also. Right now I'm not going into the discussion that how a matter will look like a wave, but what de Broglie has derived, and on the basis of that, his hypotheses were found experimentally correct. So that is why his hypothesis is accepted, and he won Nobel Prize that time. So next heading, de Broglie wavelength. Or matter wavelength. Both names can be mentioned. Okay, so we'll start this concept in terms of radiation. So according to Planck, energy of photon, that is radiation. Okay, radiation. Actually, photons are the components of radiation. So in simple way we can write it like this: is E equal to h nu, we know that, and this can also be written as hc by lambda. We know that h is Planck's constant, c is speed of light, and lambda is wavelength. Here nu is frequency. We can put equation 1 here. And also according to mass energy equivalence, Einstein's famous equation, according to Einstein's mass energy equivalence, E equal to mc square. I have already explained this term. This E equal to mc square means and mass is convertible into energy as well as energy is convertible into mass. That is why mass energy together they form mass energy. So now we can say that if a photon is moving, so it will have some mass. And remember, it is an additional information I want to give you, that rest mass of photon is 0. Remember this thing. And what about moving mass? Well, moving mass is this, and whatever in other ways we can find it out. in wherever it is required, but keeping this in mind, we can find mass of photon when it is in motion. So this is equation 2. Now combining both of them from 1 and 2, so we can write mc square equal to hc by lambda. Cc will get cancelled, so it is mc equal to h by lambda. But here he looked at this equation in a different manner. He said that this is the mass of photon, this is the speed of light of photon, so mass into speed, that is mass into velocity, which is momentum. So he replaced this as momentum of photon. So P equal to h by lambda, where P equal to mc, that is momentum of photon. Now he said that there is a symmetry, and there is a symmetry in the laws of nature. So same equation is true for any moving object having wavelength lambda. It's looking like we are just messing with the equation, but no, yeah, in actual practice it was observed that he is right. So equation 3 is true for any moving object. So lambda equal to h by p is matter wavelength or de Broglie wavelength, de Broglie actually. So for radiations as well as for matter, we can use this expression lambda equal to h by p. But things are not so simple. In physics, we make simpler thing complicated, and same thing we will do here also. Okay, so here we know a relation. Since momentum is root 2m k, k is kinetic energy here. Now what is this? Actually ke, I should write ke, but it looks like two terms are there, so that is why I was preferring to write k only. Anyway, p equal to root 2m ke. Why how this has came? So we know that p equal to mv, and also we know that kinetic energy is equal to half mv square. Now multiply both sides with m, it is m square v square. Cross multiply 2m ke equal to m square v square. Take root 2m ke equal to mv, which is p. So p equal to root m ke. Now we'll put it here. So in terms of kinetic energy, because most of the time we are able to find kinetic energy, or kinetic energy is known, then this can also be written as mke. And now all right, if this particular, now I will divide the page into two parts. So this particular formula in terms of moving charged particle, and here in terms of uncharged particle, or moving uncharged particle, or atoms and molecules. It is applicable for them also. In fact, it is applicable in our daily life, but effect can not be effectively seen. So that is why in daily life we don't use this hypothesis. We can use, but okay. So for charged particle, we know that kinetic energy of a charged particle accelerated through some potential can be given by Ke equal to QV. Why? Because we know that potential or potential difference is W upon Q. So W equal to VQ. But if this work is to pull an electron by applying some high voltage, then this work will be same as kinetic energy, work energy theorem. So that is why kinetic energy equal to QV. So we can put it there. So lambda equal to h by root 2m QV. And now for different charges, we can put their masses and their charge. And see, actually what I am going to write is only for electron. So if I am replacing for electron, then m is mass of electron, q is charge of electron. So wavelength, matter wavelength associated with an electron is equal to h upon root 2 me e. It is a subscript, so don't get confused. I'm just mixing it with m. So it is subscript e v. And see, each of these terms are constant and they have particular values. You can put them here, you can calculate, or you can memorize this: 12.27 angstrom upon root 2. Only v upon root v. Only v is variable here, so we can set different potentials and accelerate an electron, and we will get different matter wavelength. But this is this expression is for electron only. For proton, mass will change, so here this term will change. Then this exact value should not be placed, but there is an idea for that also. We can do a trick for that also. So all right, right now I'm jumping here. So here the kinetic energy, we know that for a single particle, kinetic energy, translational kinetic energy for a single particle is given by 3 by 2 kBt. Now what are these? Kb is Boltzmann constant, and T is absolute temperature. So we can put it there. So lambda for those gaseous atoms or neutrons, h upon root 2m, and in place of kinetic energy 3 kBt. This will get cancelled, lambda equal to h by root 3m kBt. That's all, nothing more to discuss about this. Now let's move to, we will focus on this. In fact, this. So we have lambda equal to h by root 2m qv. Now for electron, we know that we have earlier derived it, h upon root, not needed to write it again, but still I am writing. For electron, we know m is me and e is q is e, and this turns out to be 12.27 upon root v angstrom. Now if we talk about proton, actually in board exams these things will not come, but we have to be very conscious about these things. So in this case, proton, we know charge is E and mass is, I will write MP. Actually mass of proton is approximately 2000 times greater than mass of electron. Actually exact number is, I think, 1837 times. It is close to 2000. So I'm not mentioning these things, but what I can do is lambda equal to h by root 2mp, charge is same EV. So also what I can do a trick. I can leave this expression here, but for some higher level concepts, or if they will give this value, then how can we solve such type of problem? So I have written it 2000, actually it is 1837. So you can put for approximation this, otherwise this. So I'm putting this value 1837 ME instead of this EV. Now this time H 22 ME EE, entire this is 12.27. Similarly, we can write 12.27 upon root of 1837 V. We can be tricky, we can use, but here for mass we can replace the conversion factor. So in terms of this electron formula, wavelength for electron, we can calculate for proton also. I remind you, this type of question has never asked, and there are some different ideas to solve that also, but you can in fact do this thing also here for deuteron. What is deuteron? Actually deuterium, you people know, 1H2. So if you remove electron from it, then it becomes deuteron. So deuteron has a proton, as well as a neutron. That is why its charge is still E, but its mass is approximately double of mass of proton, and that's why it is double of that conversion factor 1837 times of that of electron. So be tricky. What will be the change here? This factor will change by this. So I'm directly doing it. 12.27 upon root of 2 into, I'm writing it exactly like this, 1837 V angstrom. And for alpha particle, alpha particle 2He4, so charge is 2e and mass is about 4 mp. It means that mass is 4 times that of 1837 me, and that is the conversion factor will change accordingly. This is for deuteron, this is for proton, and this is for alpha. So it will be 12.27 angstrom upon root of 4 into 1837 V. So these are the ways by which we can find the de Broglie wavelength. Now see, there are so many numericals you can try of your own, and later I will upload a video on important questions. Few days I would require for that. So in terms of numerical, you have to wait for a while. Okay, now an important outcome of de Broglie hypothesis, and that is deduction of Bose quantization postulate. Now what is Bohr's quantization postulate? So we know that quantization postulate is electron can revolve in those orbit for which angular momentum is nh upon 2 pi. So we can deduce that thing using de Broglie hypothesis. De Broglie, in fact. So what we can do here, we can assume an atom of radius r. So let a wave of wavelength lambda is associated with an orbiting electron as shown in figure. Then integral number of lambda will be equal to circumference. What is this statement all about? Let me explain you. Let us suppose I start wave from here. One wave, two wave, oh, exactly 3 waves are there. But in case if I draw it like this, a little bit more, one wave, and it is not completing, two waves are not exactly coinciding each other. So if this thing is happening, or something else like one wave, two wave, three wave, four wave, and that's all. So it must be a complete wave around an orbit. So first thing, 2 pi, in fact n lambda is equal to 2 pi r. I'll put subscript n. And we know this is equation 1. Since lambda equal to h by p, and that is h by mv, de Broglie wavelength, wave. So from 1 and 2, n h upon mv is equal to 2 pi rn, v subscript n. I will put subscript n also for nth orbit. I am very conscious about that. So now what we can do, we can cross multiply mv there and 2 pi here. So it is nh upon 2 pi equal to mvr. This is what Bose says. That's all. So student, that's all for today, and I'm just leaving a question for you people, that not a question, 2 questions. First, Shoaib Akhtar once bowled fastest ball of 161 kilometer per hour. Actually 162, I think. So you need to find matter wavelength associated with it. So V was 162 kilometer per hour, and mass of cricket ball is 162. In fact 162 it is 162.5, I think 163 grams. So there are lots of conversion required. Actually this question is not so tough, but calculation part is tough. And also another question, find wavelength, matter wavelength, de Broglie wavelength associated with stationary object. See you in the next video.